Hello guys, welcome to i-tutor Academy. In today's session we will start with unit 15, that is a regression. So let's see the objectives of this chapter. So after successful completion of this unit, you should be able to understand the role of regression in establishing mathematical relationship between dependent and independent variables from given data. They use the least squares criterion to estimate the model parameters, determine the standard errors of estimate of the forecast and estimated parameters, establish confidence interval for the forecast value and estimate of parameters, make meaningful forecast from given data by fitting any function linear in unknown parameters. And structure of these units are: there is an introduction part, fitting a straight line and examining the fitted straight line, an example of calculations, variety of regression model, summary, self-assessment exercise, keywords are there, further reading also here. And let's begin with the introduction part. In industry and business today, large amount of data are continuously being generated. This may be data pertaining, for instance, to a company's annual production, annual sales, capacity utilization, turnover, profit, manpower levels, absenteeism, or some other variable of direct interest to management. Or there might be technical data regarding a process such as temperature or pressure at a certain crucial points, concentration of a certain chemical in the product, or the breaking strength of the sample produced, or one of a large number of quality attributes. The accumulated data may be used to gain information about the system and or to visually depict the past pattern of behavior, and or simply used for control purpose to check if the process or system is operating as designed. Our interest in regression is primarily for the first purpose, mainly to extract the main features of the relationship hidden in or implied by the mass of data. The need for statistical analysis. For the system under study, there may be many variables, and it is of a interest to examine the effect that some variable exert on others. The exact functional relationship between variable may be too complex, but we may wish to approximate to this functional relationship by some simple mathematical function such as straight line or a polynomial, which approximate to the true function over certain limited range of the variable involved. There could be many variables of interest in the system. In a chemical plant, for instance, the monthly consumption of water or other raw material, the temperature and pressure maintained in the reacting vessel, the number of operating days per month, the monthly production of the final product, and any byproduct could all be variable of interest. We are, however, interested in some key performance variable and would like to see how this key variable is affected by the other variables. By independent variable, we shall usually mean variable that can either be set to a desired value or else take a values that can be observed but not controlled as a result of changes that are deliberately made or simply take place in the independent variables, and effect is transmitted to the response variable. In general, we shall be interested in finding out how changes in the independent variable affect the value of the response variable. Sometimes the distinction between independent and dependent variable is not clear, but a choice may be made depending on convenience or objective. Broadly speaking, we would have to undergo the following sequences of steps in determining the relationship between variable, assuming we have data point already. Identify the independent and response variable. Make a guess of the form of the relations between the dependent and independent variable. This can be facilitated by a graphical plot of data on a systematic tabulation, which may suggest some trends or patterns. Estimate the parameter of the tentatively entertained model in step 2 above, and for instance, if a straight line was to be fitted, what is slope and intercept of this line? And having obtained the mathematical model, conduct an error analysis to see how good the model fits into the actual data. Stop if satisfied with the model, otherwise repeat step 2 to 4 for another choice of the model from in step 2. And what is regression? Suppose we consider the height and weight of adult males for some given population. If we plot the pair x1, x2, height, that is weight, is equal to, and a diagram like figure 1 will result. So here is one diagram, height and weight of the 30 adult males. So here is height and weight, x1 and x2. Such a diagram you would recall from previous chapter is conveniently called scatter diagram. Note that for any given height there is a range of observed weight and vice versa. This variation will be partially due to measurement errors but primarily due to variations between individuals. Thus no unique relationship between actual height and weight can be expected, but we can note that average observed weight or a given observed height increases as height increases. The locus of average observed weight for a given observed height is called the regression curve of weight on height. So let us denote it with, there also exists a regression curve of height on weight similarly defined, which we can denote by x1 is equal to g and all square x2. So let us assume that there is two curves are both straight lines, and in general these two curves are not the same as indicated by the two lines in figure 1. So here is figure 1, and a pair of random variables such as follow, that is height and weight, follows some sort of bivariate probability distribution. When we are concerned with the dependence of a random variable y on quantity x, which is variable but not a random variable, an equation that relates y to x is usually called a regression equation. Hope you understand. Otherwise you just go through your IGNOU study material mmpc005 and it will be more clear. In between any doubts you can contact us. And linear regression. The simplest and mostly common used relationship between two variables is that of a straight line. We may write the linear first order model as like this, and that is for a given x and a corresponding observation y consists of a value or value, and here is like that the equation. And when we say that model is linear or non-linear, we are referring to linearity or non-linearity in the parameters. The value of the highest power of independent variable is the model is called the order of the model. And now in the model of the equation also here, and you just go through the equations and explanation, and it will more help you for in case any direct questions will come from this portion. And fitting a straight line, least square criterion. So least square criterion figure 2 is here. You just observe that figure, and one is independent variable and response variable also there. And in fitting a straight line to a set of data points, we would expect some point to fall above or below the line, resulting in both positive and negative error terms. It is true that we would like the overall error to be as small as possible. The most common criterion in the determination of model parameter is to minimize the sum of squares of error, or residual as they are often called. This is known as the least square criterion and is the one most commonly used in regression analysis. This is, however, not the only criterion available. One may, for instance, minimize the sum of absolute deviation, which is equivalent to minimizing the mean absolute deviation. The least square criterion, however, has the following main advantages. One is simple and intuitively appealing. It results in linear equation for solution of parameters which are easy to solve, and is result in estimate of equality of fit and interval of confidence of predicted value rather easily. So this is like that, and equation step by step is here. You just go through it. This all are this mmpc005 is based on all equation based chapters. And activity is here. And how good is regression? Analysis of variance. Once the regression line is obtained, we would like to find out how good type fit is. This can be ascertained by the examination of error. Okay, so here is based on that. And sum of squares about the mean is equal to sum of squares about regression plus sum of squares due to regression. and this shows that of the variation in the y's about their mean, some of the variation can be ascribed to a regression line and some like this to the fact that the actual observation do not all lie on the regression line. Okay, r square is equal to ss due to regression divided by ss about mean. So ANOVA table is here, one of the regression table is here. So source is there, sum of squares is there, degree of freedom is there, mean square is here. And the mean square column is obtained by dividing each sum of square entry by its corresponding degree of freedom. The mean square about regression S square will provide an estimate based on n-2 degree of freedom of the variance about the regression. A quantity we shall sigma square yx if the regression equation were estimated from an indefinitely large number of observation. The variance about regression would represent a measure of the error with which any observed value of y could be predicted from a given value of x using the determined equation. So here is an example also. You just go through this example and solution and it will more clear with the example. Okay, so equation based explanation also here and the table also here and like that. And next examining the fitted straight line we will discuss on next video. Today's section is this, and you just refer your IGNOU material parallelly. It will more clear for you. If in case any doubt, you can contact us. For more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you so much for your support.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.